So once you open up ABAQUS, you want to click with Standard Explicit Model. Go ahead and set your work directory. This will basically be, when you run a job, where it'll save your job at. So basically you just go to the folder you want. In this case it's stress analysis for me. You click on it and you click OK, and this sets it to your work directory, and you hit OK. So then you model your part, which you can have extrusion, revolution, sweep. We're going to do extrusion because I find it the easiest. So then you sketch the cross section. So for a simple rectangular beam, we'll just do a cross section of 1 by 1. So I'm doing a rectangle with coordinates 0, 0, and then the opposite corner 1, 1. As you can see, I click done, and then it comes up with this box. I'm going to set my depth to be 4, so that'll be my length of the extrusion. After you make your part, you should just go ahead and just create the mesh, which is under your part. Double click the mesh and hit seed part. This will be your node size. I'm going to do 0.5, which will be a pretty big mesh, which is fine for this simple thing. So then you go to mesh control and you can choose if it's what the type of mesh is. We're going to leave it as hex. Then you can go into element type, and linear is a good one, and then we'll do take off reduced integration, so it just shows an 8-node linear brick. And then we hit mesh part, we hit yes, and it'll mesh the part. So that's done. Next we're going to assign the material. You have to look up your values for Young's modulus and Poisson's ratio. I just put in 100 and 0.3, just some simple numbers. Then you assign a section. Solid homogeneous is good for these solid ones, and it puts 2 to 1. Then under your part, you have to assign the section to your part. So we click the part, we click OK, and it says section 1, we hit OK. Then we have to make an assembly. Since it's just one part, we'll double click instant, and it'll automatically highlight our part. We just hit OK. So now we can add our steps in. We do static general. And then we come into here, and you can turn nonlinear geometry on or off. We'll leave it as off for now, with time step 1. Then we come down here to our boundary conditions. This is basically like how you set it as like a fixed or cantilever, or whatever you're going to do. So we do displacement, rotation, then we select what we're going to do. So I'm going to fix this one node. And the U1, U2, U3 directions are your displacement in X, Y, and Z respectively. So we set those to 0. That means it's fixed. Then we're going to do another one to make a rolling thing. And so we're going to fix it only in the Z. This is a uniaxial tension setup. And then we're going to apply the force, the load on the other side. So we're going to choose surface traction, which is a distributed load. And then in there we put the face we want to put it on, because we're going to go down in the Y direction. So we change it to general, and then we assign our vectors. So the first point 0, and the second point of our vector is going to be 0, negative 1, 0 to make it go down in the Y. And then it comes back up, and we'll just set the magnitude to be 1. And as you can see, it goes down as such. And then that's all done. Now all we have to do is create a new job. We'll just call it try. You just hit continue, you don't mess with anything here, you hit OK, and then you go ahead and submit the job. Just right click and hit submit. Now this one had some issues with some of the boundary conditions. I would have to go back and double check why it didn't want to run. You can see me trying to mess with it here because it aborts a couple times. I didn't have that much time to think about it, so I kind of just threw some boundary conditions in there. So it aborts here. I'm not sure why. I thought the force may have been too large for it, or maybe the time step wasn't big enough, or maybe it needed to be non-linear. I'm not sure. I eventually just ended up changing the boundary condition and just fixing the whole face. Which you will see here, I think, in about a minute. As you see, I'm trying to fix, I've changed the force to 0.1. Another thing is there's no units in ABAQUS. You have to basically use your own units and know what it comes out to be. It's kind of tricky, but it also gives you more usability. I mean, you can kind of set up what you want it to come out as. So if like you used kpsi or pascals, well, then you might want to be in meters, or it just depends. You have to think about it, what it would be coming out as. So like, you're better off just putting it in as pascals and psi. That way you know your displacement will come out in either meters or in inches, and not like thousands of inches or something. But these are the steps you have to follow every time just to get it to run. And sometimes it doesn't run, like you can see here. And so I'm trying to change the time step to a 10. And I submit it again and it still doesn't work. And so then I think I just end up changing the boundary condition. Yeah, I just delete both. Something was wrong with them. And then I add a new one. And I end up just fixing the other side completely. And then I rerun it, and it runs. So now it's completed. So now you can see your results by clicking this little colorful thing. It'll show your stresses. If you follow through, you can skip the displacement of one node by hitting the information button, and you can also click the drop down and change to different types of stresses, from von Mises to max principal to S11, which is your stress in the x direction, or S22, which is your S in the y direction, or S33, which is your x in the z direction.